Hello everyone, we're here today to talk about Math 100, section 1.6. And for section 1.6, it's going to be all about multiplying and dividing. Let's dive in with a property, multiplication property of 0. Well, anything times 0 is equal to 0, right? 0 cancels everything out when multiplying. Anything times 0 is equal to 0. Now, multiplying numbers with different signs. The product of numbers, I'll use the hashtag symbol, with, I abbreviate with, different signs is always negative. So a positive times a negative or a negative times a positive is always negative. Let's take a look there. 8 times negative 5. Well, what is 8 times negative 5? Well, I know it's going to be negative because different signs, and 8 times 5 is 40. So it'll be negative 40. How about my second example? Negative 9 times 1/3. Well, I need to be careful because I have fractions and non-fractions, right? So I'm going to make it negative 9 over 1 times 1 over 3, which is negative, because negative times a positive is a negative. 9 times 1 is 9 in the top. 1 times 3 is 3 in the bottom. And now, do I know 9 over 3? Yeah, 9 over 3 is the same thing as plain old 3, right? So I know the answer is negative 3. Notice I worked with the negative sign outside of the problem. Same here. If we want to do 6.2 times 4.1, but one of them is negative, I know the answer is going to be negative right away, because it's negative times a positive, right? Now, on my calculator, I'm not going to worry about the negative sign. I'm just going to type in 6.2 times 4.1, and I get 25.42. So that means the answer must have been negative 25 and 42 hundredths, right? That must have been the actual solution to the problem. So let's keep that in mind, that we don't need to work the problems. How about multiplying two negative numbers? What's a negative times a negative? A negative times a negative number is a positive. So a negative times a negative is a positive. Let's take a look. Negative 9 times negative 2. I know the answer is going to be positive. Positive what? 18, because 9 times 2 is 18. If I look down below, I've got negative times a negative. I know the answer is going to be positive, so now I'm just going to worry about the fractions. 2/3 times 3/2. In the first part, I have 2 in the top, and the second I have 3 in the top. 2 times 3 gives me 6 in the top, over. 3 times 2 in the bottom gives me 6 in the bottom. So the negatives canceled out, right, because negative times the negative is positive, and the fraction became 6 over 6, which hopefully we all agree simplifies to plain old 1, right? 6 over 6 is plain old 1. Same thing here, negative 0.5 times negative 1.25. I already know the answer is going to be positive. I just need to figure out what it is. 0.5 times 1.25 gives me 0.625. So once again, I just have to worry about the sign of the answer. And that's actually going to be our hint here. Hints, we can figure out the answer's sign first, before we worry about the product. So we've got that power at our disposal, right? We can figure out the answer sign before we worry about the product. So that's multiplication, right? What about division? Well, we're going to start off with a definition. What does it mean to do A divided by N? Well, that's the same thing as A times 1 over N. Now here we have to assume n is not 0, right? Because you can never divide by 0. So Division is the same as multiplication by a fraction. An example of that, if I wanted to do 10 divided by 2, 10 divided by 2 is 5, right? I could also think about it as 10 times a half, because 10 times a half is also 5. So when dividing sign numbers, the rules, division and multiplication, have the same rules. So dividing sign numbers, if I have, I'm going to use some symbols here. If I have a positive divided by a positive, the answer is always positive, right? But if I have a positive divided by a negative, then they're mismatched signs, right? So the answer will be negative. Similarly, if I have a negative and I divide it by a positive, that's going to give me a negative. And then lastly, a negative divided by a negative, well, that's two negatives, right? And when multiplying, two negatives become a positive, so it'll be the same for the division. So with division, if they have the same sign and you divide, they become positive, right? Negative and negative make positive, positive and positive make positive. But if they mismatch, they stay negative, right? So let's take a look at some examples of that. 8 divided by negative 2. Right away, positive and a negative, I know the answer is going to be negative. Now I worry, what is 8 divided by 2? 8 divided by 2 is 4, so I know the answer is negative 4. In my next example, negative 100 divided by positive 5, they have different signs, so I know the answer is negative right away. What is 100 divided by 5? That gives me 20, right? 100 divided by 5 is 20, so I know the answer is negative 20. Now, in our third example, negative 4.5 divided by negative 0.09. I know the answer is going to be positive because it's a negative divided by a negative. What is 4.5 divided by 0.09? Gives me positive 50. Notice I did not worry about the negative signs while I was typing into the calculator. Let's see what would happen if I type negative 4.5 divided by negative 0.09. It gives me 45.41. That doesn't seem right. Let's type it again. Negative 4.5 divided by negative 0.09. Now it gives negative 4.59. That's also not right, is it? Something funky is going on. My calculator doesn't like using this button as a negative button. Be careful of that. If you know the rules, you don't have to worry about the signs, right? You can just type in 4.5 divided by 0.09. You don't need to type the negative signs, right? Because you already know the sign of the answer. So just be cautious of the calculator. Sometimes it can trip you up. Now here I've got a negative times or negative divided by a negative. That's the answer is going to be positive, but it's fractions, right? With fractions, we always want a KFC. We always want to keep, change, and flip. Now, negative times a negative is still a positive, so I know my answer is still going to be positive. 1 and 4 make 4, and 8 and 3 make 24 when I multiply in the bottom, right? And then this reduces by dividing by 4 in both the top and the bottom to give me 1 over 6. So negative 1/8 divided by negative 3/4 is positive 1/6. So just be careful with the signage. Make sure you're careful with the signs, right? How about division involving 0? Well, with division with 0, there's 3 possibilities. Let's say A isn't 0. A is some number, any number in the world except 0. Then 0 over A is always equal to 0. If 0 is in the top, you always get 0 as an answer. A over 0 is undefined. There is no answer to A over 0. You can't divide by 0. It is undefined. It does not have an answer. And the third combination, what about 0 over 0? Well, that's also undefined, because there's a 0 in the bottom. You can never divide by 0. That is the most powerful rule for division. Never, never, never divide by 0. So always keep that in mind. Now, I've got a note about equivalent forms here, and it has to do with negative a over b. You can write the negative sign out in front of your fraction, or just in the top, or just in the bottom. They all mean the same thing. This is the ideal form, though, with the negative sign out front. It's the least ambiguous. It's the clearest one for what is going on. Sometimes negatives get lost in the mixture when you put them in the top or the bottom. So try and get in the habit of writing them out front. All three of these mean the same thing, but this is the ideal way to write it. So just be aware of that the negative sign might be placed in different areas. Now let's take a look at some order of operations types problems. Here we've got some examples that require us to work through them. Here I've got negative 9 times 2 minus negative 3 times 2. Well, I always start with grouping symbols, but if I look, there's nothing to do inside of any of them. So I'm going to skip right into exponents. No exponents. I'm going to skip right into multiplying and dividing. I'm already on the third step of my order of operations. I go left to right. Here's a multiplication. Negative 9 times 2. Negative and positive make a negative. 9 and 2 make 18, right? So I did that one first. And then I'll copy everything else down. Now, next, I still do my multiplications, right? I'm still multiplying. I haven't finished multiplying yet. So I've got negative 18 minus, when I multiply here, negative 3 times 2. Negative and a positive make a negative. Negative 6, right? 3 times 2 is 6. Notice I kept the parentheses to placehold my negative number. That's just a habit we should be in. It's always nice to keep those parentheses around a negative number, just so you remember it's a negative number. It's easy to see the negative sign. Now, negative 18 minus negative 6, that looks like double negative to me, so I'll make it negative 18 plus 6. I'm adding two numbers with different signs, so I need to think of the difference. 18 and 6 have a difference of 12, and the 18 is bigger, so the 12 will be negative, right? The answer will be negative 12. So we got to make sure we're going step by step. Let's jump over here to number 3 next. We've got grouping symbols, so I'll start there. Negative 6 plus 2 parentheses 3 minus 5. That looks to be about negative 2 from my perspective, right? Where do I go next? Well, I'm done with my groups. I would go to exponents. There's none. So I'd go to multiplications. There is a multiplications, right? Negative 6, 2 and negative 2. Well, positive and negative multiply to be negative. 2 and 2 make 4, right? I'm adding two negative numbers, so I know the answer is negative. 6 and 4 add up to 10. So I get negative 10 for that second example. Sorry, that's the third example. The second example's down here, right? Second example, though, I've got absolute value signs. Remember, these are treated as a group. So I need to work inside first. I need to figure out what is going on inside. Well, inside, I've got 3 minus 2 times 4. I'm going to start right here. You multiply before you subtract, right? You always multiply before you subtract. So, 3 minus 2 times 4 is 8. Minus 2 parentheses negative 6, right? Now, I'm still in this group. I haven't sorted out this absolute value sign yet. I got to do 3 minus 8, right? 3 minus 8 is negative 5. And then I'll copy down the minus 2 times negative 6. Now, I'm ready to do the absolute value. I've figured out what's going on inside, right? I've worked that group out. What is the absolute value of negative 5? Well, hopefully we all agree it's positive 5, right? Remember, absolute value turns negative numbers into positive numbers. And then I'll copy down everything else. Now, careful. A lot of people might want to do 5 minus 2 now, but that's not what we're doing, right? We need to multiply next. Multiplying comes before subtraction, remember? Multiplying happens on step 3. It's multiply and divide on the same step, right? Add and subtract happens on step 4. Make sure you're doing your multiplications first, right? 5 minus 2 times negative 6. Positive times a negative is negative 12, right? Double negative. 5 plus 12, which hopefully we all agree is 17, right? So I got 17 as a final answer for my second example. My fourth example, I've got big fraction bars. Remember, you always treat the top and the bottom separately whenever you see a big fraction. So in the top, I've got some multiplications and some subtractions. So in the top, I'm going to start right here with that multiplication, right? I'm going to do 5 times negative 2 first. I'm going to copy down the whole fraction over 2 parentheses 1 minus 6. So in the top, I start there. In the bottom, I start here, right? I work with the group in the bottom. So in the top, I'm going to get negative 10 when I do 5 times negative 2, right? Minus 3 times 4 will still be there. 3 times 4 over. In the bottom, which step did I do first? Well, I did 1 minus 6 first, right? 1 minus 6 gives me negative 5. So I did one step in the top and one step in the bottom, right? I did this step in the top and this step in the bottom. Now, in the top, what do I do next? I'm still multiplying. I got to do 3 times 4 next. So negative 10 minus, well, 3 times 4 will be negative 10 minus 12, right? 3 times 4 is 12. In the bottom, there's only one step left. I got to do 2 times negative 5, which hopefully we all agree is negative 10. So I'm done with the bottom. In the top, I still have to figure something out. I've got to do negative 10 minus 12. Well, if I start with a negative 10 and I want to subtract 12 from it, that's the same as adding the opposite, right? Adding negative 12, however you want to think about it. Either way, that should become negative 22 over negative 10. I have a negative over a negative, so I know that this can become positive 22 over positive 10. How did I know it was positive? That's the rule for division, right? Negative divided by negative is positive. Now, can I simplify? Does anything divide both the top and the bottom? Yeah, 2 does, right? I'll divide out a 2. 22 divided by 2 is 11. 10 divided by 2 is 5. So I'll get 11/5 as my final answer for this problem. Notice we took it one step at a time. We treated the bottom and the top as separate problems, right? We worked in the top and bottom separately until the very end. Always work big fractions in that manner. Figure out the top, then separately figure out the bottom, then get your final answer, right? Worry about the big fraction part at the last step. It's separating them into groups, right? Just be aware of those groups. Now, how about plugging in some values? How about evaluating some expressions? So here we've got evaluating this expression for x equals negative 1, y equals negative 2, and m equals negative 3. The very first step in these type of problems is always plug in. So, I've got parentheses 3, let's see, x is negative 1, so I'll put a negative 1 there, plus 4 parentheses y is negative 2, and then I've got another parentheses negative 2, and I've got m is negative 3. So I have now plugged in successfully. Now I need to figure out what steps I do first. Well, I've got 2 groups, right? I've got a group here and a group here. I got to figure out what's going on in each of these groups. In the first group, I've got multiplications and additions. I'll do the multiplications first. 3 and negative 1 make negative 3 when you multiply them. And if I wanted to, I could do this at the same time, right? Because that's what I'm going to do second. I'm not going to do the addition. What is 4 times negative 2? That's negative 8, right? So I did both multiplications at the same time. If we're going to multiply, we can do both multiplications, right? In the second group, negative 2 and negative 3 make positive 6. So in the second group, I get positive 6. I'm done with the second group, right? I still need to figure out the first group, though. Negative 3 plus negative 8, they have the same sign, so it'll stay negative, right? Negative plus a negative is always negative. 3 and 8 add up to 11. I've still got 6 floating on the end. Don't forget the 6. Negative 11 times 6. Negative and a positive make a negative. 11 and 6 make 66. So I can work the problem out in the same manner as those ones on the previous page. I just have the new step that I need to plug in first. If you can do the questions from this page, you can do the questions from this page. The only new step is plugging in your x, your y, and your m. So let's take a look here at our second example. Actually, sorry, third. I like to go left to right, so I'm going to do the third example here. We've got 4, and then we need to do y squared plus, let's see, x, which is negative 1, over m, which is negative 3, right? So I've got a big fraction. I've got top group and bottom group. Good news for me, bottom group, already figured out, right? So I just got to worry about the top group. In the top group, I would start with the exponent, right? I got to start with the exponent. Exponents first. So I'll have 4. What is negative 2 squared? Well, I need negative 2 squared. Tells me to multiply by itself twice. Negative 2 times negative 2 is positive, right? Negative and negative make positive. And 2 and 2 make 4. So negative 2 squared becomes positive 4. Plus I've got that negative 1 floating on the end over negative 3. In the top, I multiply second, right? You multiply before you add. So I'm going to get 4 and 4 make 16 plus negative 1 over negative 3. Now in the top, I'm ready to add. It's the last thing to do. 16 plus negative 1 is 15, right? Over negative 3. Positive divided by negative, the answer is going to be negative. 15 divided by 3 works out nice and evenly to be the whole number 5, right? So that answer becomes negative 5 once I've simplified. In our second example, we want to do the same thing. We plug in first. Negative 1 squared minus 3 parentheses negative 2 squared. I plug in x and y, right? Once again, I got to do my exponents first. So negative 1 times negative 1, if I need to square it, what's negative 1 times negative 1? Negative and negative make positive 1, right? Minus 3 parentheses negative 2 squared. We just said that was 4 over here. Shouldn't have changed, right? Now I've done my exponents. Now I'm ready to multiply. We multiply after exponents. 2 times 1 is 2. 3 times 4 is 12. So I multiplied here and multiplied here, right? And then 2 minus 12, the last step. The last thing we do is the subtraction. That should give me negative 10. So when I multiply in the last step, I get negative 10. And now, because I write kind of big, I'm going to leave myself some extra space for number 4 here. When I look at number 4, I notice something, don't I? The numbers are fractions. I am going to plug in my x and y as fractions. So let's take a look here. I've got 3/4. 3/4. X is negative 1. So I'm going to put negative 1, and I'm going to put it over 1. Because you can always put fractions or whole numbers. You can always put the number over 1, right? Then I've got plus 5/8. Now I need y. Y is negative 2, so I'll put 2 over 1. I'll make sure I don't forget the negative though, right? And parentheses, then I got parentheses negative 1/2. M is negative 3, so I'll put m as negative 3 over 1. And notice I wrote some of my parentheses bigger to make sure I remember which ones are paired with which other parentheses. Make sure you keep them together, right? Now, I got groups here. I've got a group here and a group here. So I got to work out those groups. In my first group, there's a lot going on, right? But I know I'm going to add last. I multiply before I add. So I'll do the multiplications first. 3/4 times negative 1 over 1. Positive and negative make a negative. 3 and 1 make 3. And 4 and 1 make 4, right? It should make sense that we get 3/4 because we were multiplying by 1. 5/8 times negative 2/1. Well, that's going to be plus. It's going to be a negative number when all is said and done, right? 5/8 times negative 2. Let's see, I'm going to get 5 times 2 is 10 over 8 times 1, which is 8. Here, negative times a negative becomes a positive in this group. And I get positive, what is it going to be? 1 times 3 is 3. 2 times 1 is 2. So I get 3 halves for that value. Now, I figured out the second group, but I'm still figuring out the first group, right? I got to work with that group still. I haven't worked that group out yet. I need to add. When you add fractions, you need common denominators. What is a common denominator between 4 and 8? Well, it's 8, right? I can multiply this by 2 and this by 2 to make this an 8, right? So I'll do that. It's going to give me negative 6 over 8 plus, we still have that negative 10 over 8. And we still have that 3 halves. Right? Now I'm ready to add. We got to add 6 over 8 and 10 over 8. They're both negative, so I already know my answer is going to be negative. 6 plus 10 is 16 over. The 8 doesn't change in the bottom, right? That's going to stay 8. Times 3 over 2. Now, you might see that this reduces to 2. I'm not going to, because I need to multiply. Negative times a positive is negative. 16 and 3, that makes what? What does 16 times 3 make? Well, 48. 8 times 2 makes 16, which gives me 48 divided by 16 is 3. And don't forget the negative sign, negative 3. So that one was a little cumbersome, right? There was a lot of steps in that one, a lot of fraction arithmetic. But notice, still the same steps, right? Plug in, then you do your grouping symbols, then you would, if you had exponents, you would do exponents, then you do your additions, your multiplications and divisions, then you add and subtract, right? Always that order. Plug in, grouping symbols, exponents, multiplications and divisions, adds and subtracts. Always that order. Now let's look at some word problems. Let's real quick translate some sentences into symbols. This will be a skill that'll come useful when we get to word problems. So it says, the product of 12 and the sum of 3 and negative 6. So I'm producting. So I need to multiply. What am I multiplying? Here's one part, and here's another part. So I take 12 times, this part looks like a group, so I'll make a group. It's a sum, so I'll put a plus. What am I summing? 3 and, let's see, negative 6. Maybe I'll put parentheses around the negative 6 as a placeholder, right? Notice I had a group, so I kept it as a group. Here, we have twice. Twicing something is multiplying by 2. What am I twicing? A group. The difference. Difference is subtraction. What am I subtracting? 8 and negative 4. So that'll become 2 times 8 minus negative 4, right? Make sure you're aware of where you need to place the grouping symbols. Where do they go depends on the grammar. Same thing here. 2/3 of, well, to take 2/3 of something, I do 2/3 times whatever that is. The thing I'm taking 2/3 of, once again, is a group. It's a group that's going to have a sum of negative 5 and negative 3. Notice I haven't solved any of them because it just says translate. If it said to solve, I should work these out as well. Now, 15% of the difference between 14 and negative 2. Same thing. It's 15% of a group. Let's worry about the group part first. The difference of 14 and negative 2 is going to be subtraction. Difference is subtraction, right? How do I do 15%? Well, I can do 15 over 100, right? Percent is always out of 100. That's why it's invented. That's why we have percentages. It's always out of 100. Next, we have the quotient. So I'm going to have a division bar. The and tells me the stuff before it goes on top. 14. The stuff after it goes on bottom. Let's see, a sum, -9, and 2. So the and helps me keep things separate, right? Continuing with the word theme on the next page, we've got 5 more examples. It says the product of 5 and -6 divided by the difference of -7 and 8. So the divided by is the breaker, right? Notice the comma. Just like in English, commas tell you that it's a pause or something of that nature, right? There's a break in the sentence. So divided by, what came before the division? 5 times -6. Product is times, right? Product is times. 5 times -6. Divided by the difference. So I'm subtracting. What am I subtracting? -7 and 8. So in that one, I had another big division, and it separated the problem. Notice how the grammar was different than the previous example, though. The previous example used the word quotient. This one used the phrase divided by, right? They're synonyms. 3 times a number. Here, remember it said if we don't know the value of a number to use x on page 3. Use x as a variable if you need to. So here I've got a number I don't know, and it is 18. Is equals bar. -18 on that side. This side I need 3 times the number. 3x. Here, the sum of a number and 9 is 12. Is 12 sum of a number and 9. I don't know what the number is, right? So I use x. The difference of a number and 5 is 0. All right, well, I got that side figured out. Difference is subtraction. What am I subtracting? A number, x, and 5. Number 10. The quotient of 24 and a number is -2. Is -2. So I got to figure out what was going on here. Quotient, that's division. What am I dividing? 24 and a number. Notice I'm translating the words as I go, right? I'm thinking about where certain symbols will appear. Equal signs, good places to start. Notice I started with the equal sign in each of these examples. It's a good place to start because the stuff after the equal sign is the stuff after the word that implied equals. Here the word was is, right? Is tells you need an equal sign. And there's some examples of translating words into symbols. And we'll get more practice with this as we dive into more word problems, right? And that is the end of section 1.6. As always, thanks for joining me, and I will see you next time.